This is a 28BYJ stepper motor connected to an L298 H bridge, which is being driven by an ESP8266. The stepper motor connects to our H bridge via 5 cables that come out of the motor. The red one goes to a 12-volt supply. The other cables go into the output ports of the L298 board. The ESP device controls the L298 H bridge via these data pins. These 2 crocodile clips connect to a 12-volt supply. The ESP device gets 5 volts because the H bridge has an inbuilt regulator. Here you can see the stepper motor in action. The ESP is running MicroPython. We've developed a Python module to send the correct sequences to the stepper motor. You can see the sequence for clockwise motion here. Motion is achieved by energizing the motor's 4 input wires, orange, yellow, pink and blue, in sequence. There are 8 of these sequences, the first sequence being just the orange wire on, the second sequence being orange and yellow, the third sequence being yellow. I won't go through all of them, but as you can see, when you go through these sequences on the motor, it will result in the motor turning. For anti-clockwise motion, just go in the opposite direction. We found that the speed that you could make changes to the phases on the motor was 1000 Hz. Anything above this, and the motor wouldn't be able to turn properly. The motor was getting a little hot, so I unplugged the voltage supply from the motor, which was previously on 12 volts, and connected it to ground. This is because the outputs of the H bridge will supply 12 volts to the motor, and it can then be sunk through this ground connection. Which means when the system is idle, the default status of the output of the H bridge will be unenergized, meaning that the motor won't have any current running through it and will stay cool.